Hello, good evening, students. Welcome you all for this third session on basic concepts of chemistry. And let us do quick revision. The last class, mainly we dealt with scientific notation as well as significant figures. Yes. So, today's class, I think in the last class I also discussed about various laws of chemical combination. So that we will look into it today. Yes. So few of them are law of conservation of mass, law of constant proportion or fixed proportion, law of multiple proportion, law of reciprocal proportion, Avogadro's law, Gay-Lussac's law, and Dalton's atomic theory. Yes, so these laws are very fundamental and are applicable to every type of elements or compounds. That's why we are learning this in the beginning of the chemistry. Okay, and whole of physical chemistry is dependent upon all these laws. So, if you are very thorough with all these laws, then it's very easy to go ahead with physical chemistry. You have to apply this in every step of physical chemistry. May that be class 11, class 12, any topic, you will have to, these are like fundamental things in physical chemistry. Yes, having told this, and also in competitive exams, direct questions can come from this. Okay, yes, for example, law of conservation of mass, direct questions will come. So you have to make reactant and product mass balance. Yeah, so such kind of questions are also expected. Rather, yeah, though they are very rarely asked, but still they can ask that. Okay. So, going with this law of conservation of mass, for any chemical change, total mass of active reactants are always equal to mass of product formed, as fundamental as it is. Okay, it is saying that mass of active reactant should be equal to mass of total product formed. Okay, so with that understanding, now let us try to find out if there is mass balance on all these reactions. Okay, so if I look at the first one, 2 magnesium plus 1 O2 gives 2 magnesium oxide. So what does that mass balance means, or law of conservation of mass means? Total mass in the reactant side should be equal to total mass in the product side. So here, since magnesium and oxygen O2 is combining, we need to consider mass of one fundamental particle maybe. Okay, so I'll consider atomic mass of magnesium. What is atomic mass of magnesium? It's 24. Okay. And molecular mass of oxygen is 32. So when and since there are two atoms of magnesium, I'll consider 2 mg, which is 24 into 2, 48. So 48 plus 32 will be 80. Whereas if I take on the right side, it is 2 mgO. You can cross verify how much it will be. 2 mgO. Yes, it will be 2 into 24 plus 32, which is 48. 2 into 24 plus 16, sorry, 24 plus 16, because oxygen atomic mass is 16, and 2 is 2 molecules of magnesium oxide. So I am considering 2 into 24 plus 16, which is 2 into 40 equal to 80. So as you can see here, mass of reactant is 80, mass of product is 80. So that means this reaction obeys law of conservation of mass. Clear? Yes. Whereas if I go to second one, okay. If I go to second one, it is saying C3H8 C3H8 plus O2 gives CO2 plus H2O. So in this case, as you can see here, C3H8 whose mass is how much? 3 into 12 plus 8 into 1. Correct? Because atomic mass of hydrogen is 1, atomic mass of carbon is 12. So it is 3 into 12 plus 8 into 1, which is 24 plus 8, 32. Sorry, 12, 3, 36 plus 8 is equal to 44. Yeah. Whereas if I consider O2, it is 16 is the atomic mass of oxygen. 16 into 2 is 32. Okay. Yeah. And when I look on the right side, so in the left side, reactant side, total is 44 plus 32, which comes out to be 76. Whereas if I look on the right side, CO2, all of you might be knowing molecular weight of CO2 is 44 plus molecular weight of H2O is 18. So 44 plus 18 is, obviously it should not be 76. It will be 62. Okay. So 76 and 62, it's not matching. So it does not obey law of conservation of mass. Whereas if you look at this as well as this, these two obey law of conservation of mass. Clear? So yeah, and this is the basic thing by which we got balancing of an equation. Balancing of an equation means you make every equation satisfy law of conservation of mass. Then your equations are balanced. Okay, so that's why you can see over here P4 plus 5O2. Why does that 5 come? That 5 comes because oxygen has to be balanced. Okay, then only mass balance will happen on the reactant as well as product side. Clear? Yes. This is the first law, which is law of conservation of mass. Hope this is very easy. Going ahead, yeah, only except few, all other laws are very fundamental, and few may say it is common sense. Okay, yeah, law of constant composition. So if I take, let's say, molecule H2O, so if I take H2O, always water means you will remember H2O, isn't it? Yeah. So what does that mean? Every molecule will have definite composition of atoms. Okay. So water means 2 hydrogen atom and 1 oxygen atom. So that will give me water molecule, isn't it? A chemical compound always contains same elements in definite proportion by mass. Okay, so as you can see here, A16, oxygen atomic mass is 16 and hydrogen atomic mass is 1, but since 2 are there, into 2. So in water, 2 grams of hydrogen, if it is there, 16 grams of oxygen will be there. That's what they are saying. It will be in a definite proportion by mass, and it does not depend on the source of compound. Okay. So for example, if you take composition of CO2, it will be always in the ratio 0.375. Okay. Yes. So this is the question, and this type of question you can expect in JEE as well as NEET. Okay, this kind of questions you can expect. So question says 6.488 gram of lead, lead is Pb, combined directly with 1.002 gram of oxygen to form lead peroxide. Lead peroxide means it is PbO. PbO. Okay. Lead peroxide is also produced by heating lead nitrate, and it was found that the percentage of oxygen present in lead peroxide is 13.38%. Okay, so yeah, two different ways they are giving us. In one way, they are telling in lead peroxide, 6.488 gram of lead and 1.002 gram of oxygen was taken and combined to form lead peroxide. And in another way, lead nitrate was heated. Okay, when it was heated with oxygen, that also gave lead peroxide, in which percentage of oxygen is 13.38%. So basically, percentage of oxygen in first PBO or second PBO should be 13.38% only, isn't it? Because that's what law of chemical constant proportion says, isn't it? So now we will have to prove this from first way. We have to prove that in this also the percentage of composition is 13.38 only. Then we are proving law of constant composition. Yes? Okay. So, yes. So as you can see here, weight of peroxide formed is 7.490 grams, and out of the 7.490 gram, 1.002 grams is oxygen. Okay, that's what they have told. So if you want to find out percentage oxygen, it will be 1.002 divided by 7.49. How much will this be? This will come out to be equal to 13.38%. Yeah. Either you can directly do this way, into 100 will give you the answer, or you can also do cross multiplication, as you can see here. 7.49 gram of lead peroxide contains 1.002 gram of oxygen. That means 7.49 gram contains 1.002. So 100 gram, they are asking what will be oxygen. So how will you do? 100 into 1.002 divided by 7.49. That's what we did. Set. So yes, finally we are proving that actually no matter what way you do it, always percentage of oxygen in lead oxide should be 13.38%. Clear? Yes. So this is proving type of question. There can be numerical also. This question itself can become numerical. For example, if they didn't give us this value and they asked us to find out percentage of oxygen presented, okay, then how to find it out? Same procedure. Finally, we will get the answer as 13.38%. Clear? Yeah. Going ahead. Yes. So the conclusion is that conclusion is that this is same as the mass percent of oxygen from second sample. Hence it satisfies law of definite proportion or law of constant composition. Yeah. Next one is law of multiple proportion. Yes, what does this law say? When two elements combine to form two or more than two different compounds, then the different masses of one element which combine with fixed mass of the other element bear a simple ratio to one another. Little difficult to understand, but for that let us take an example. Okay. So here you can see that a fixed mass of carbon, that is 12, can combine with oxygen either in this way, in which 16 gram of oxygen, half of O2 mass is 16 into 2, 32, half of that means 60, correct? Either carbon can combine with 16 grams of oxygen or it can combine with 32 grams of oxygen. Okay, and if you look at this ratio 16:32, it is in a simple ratio form, which is 1:2. Okay, see here, 16:32, 1:2. So one particular atom, when we consider it as to be fixed mass, then that fixed mass can combine with other atom in two or more different forms, but the proportion will be a simple ratio. Okay, they will combine with the other element, which bear a simple ratio to one and another compound. Okay, yeah, yes. So which of the following, yeah, based on law of multiple proportion, you have to answer now. Which of the following statement indicates law of multiple proportion is being followed? Okay, yes. Sample of carbon dioxide taken from any source will always have carbon and oxygen in the ratio 1:2. Yes. Sample of carbon dioxide taken from any source will always have carbon and oxygen in the ratio 1:2. Is it law of multiple proportion? It's definitely true, but it is not law of multiple proportion. Carbon forms two oxides, namely CO2 and CO, where masses of oxygen which combine with fixed mass of carbon are in the ratio 2:1. This is what law of multiple proportion says. Yes. So this kind of questions can be expected. Okay. As well as there could be sometimes basic questions like which of the following defines law of multiple proportion? It can be as simple as this also. Okay. So be prepared. These are all little scoring topics. So you should not ignore this. When magnesium burns in oxygen, third statement if you look, when magnesium burns in oxygen, the amount of magnesium taken for the reaction is equal to the amount of magnesium in magnesium oxide form. Yes, this is also true. However, this is not a law of multiple proportion. It is law of conservation of mass. At constant temperature and pressure, 200 ml of hydrogen will combine with 100 ml of oxygen to produce 200 ml of water. This is something else which we may look ahead. Okay. Yes, law of reciprocal proportion. This is something which many often I have seen students get confused with. Okay, so I'll explain to you in a very basic way. So listen carefully. Okay, law of reciprocal proportion. If two elements B and C react with same mass of a third element, B and C react with same mass of third element A, the ratio in which they do so will be the same or simple multiple if B and C react with each other. Okay, yes. So for example, if let's say H is my common element A and B and C be oxygen and sulfur. Okay, so then we know that oxygen and hydrogen can form H2O and hydrogen and sulfur can form H2S. Yes. So now what does this law of reciprocal proportion says? If these two elements, oxygen and sulfur, are combining with a fixed mass of third element, okay, then they themselves can also form compound, and that will be a simple multiple if B and C react with each other. So that means what? If S and O react with each other, they will form SO2 or SO3, isn't it? So SO2 means the mass ratio, sulfur is 32, oxygen is 32. So it is 1:1, yeah, which is simple multiple. Or SO3, if I take 32:48, which is 2:3. Getting it? So it is a simple multiple. Okay, 1:1 or 2:3. Yeah, basically a small whole number. Okay, yeah. So they are giving us the example of sulfur dioxide, carbon dioxide. where sulfur and carbon are combining with fixed mass of oxygen, which is 32. Okay, so when these sulfur and carbon, when these two combine with each other, they can combine in a way that it will be a simple ratio. Here it was 12 is to 32. Here it is 12 is to 64. So as you can see here, 3 is to 8 is their ratio over here. Mass of ratio is 3 is to 8. But when they are combining, the mass ratio is 3 is to 16. So the molecule formed, ratio of mass in a molecule formed will be multiple of the ratio of masses that are involved in this as well as this compound. Getting it? So that's what law of reciprocal proportion means. Okay, so the ratio obtained by the third combination, which is among B, C, will be simple multiple of their masses when they are combining with A, when they are combining with fixed mass of A. Okay, the two ratios 1 and 2 are related to each other by 3 by 8, 2 into 3 by 16. Okay, so it is 2 is to 1 ratio. Basically, it is a multiple. Okay, so for 3 is to 8, if you multiply it with 1 is to 2 or 1 by 2, you will get 3 is to 60. So it is a simple multiple. That's what law of reciprocal proportion means. Clear? Yeah. Next one, Avogadro's law. This law was proposed long back, but then this was getting so much opposition from Dalton's law. Okay, yeah. What does that law say? Equal volumes of gases under identical temperature and pressure, gases, note it down. Okay, equal volume of gases under identical temperature and pressure conditions contain equal number of molecules. Okay, yeah, so volume and number of molecules are related in case of gases. That's what Avogadro's law says. Yes, so if say I am taking H2 gas and O2 gas, then the volume of H2 gas is say 1 liter, and if I am taking O2 gas to be 1 liter, then the number of molecules of H2 will be equal to number of molecules of O2. Getting it? Why these two will be equal? Because volume is equal. Clear? Yeah, this is what Avogadro's law means. Next one is Gay-Lussac's law of combining volumes. At given temperature and pressure, the volume of all gaseous reactant and product bear a simple whole number ratio to each other. Okay, so what does that mean? If say I have this example, H2 plus Cl2 gives 2 HCl. What does this equation imply? Gay-Lussac's law says that if you are taking 1 liter of H2 and 1 liter of Cl2, you will get 2 liters of HCl. Okay, provided all are gaseous. Okay, so that is Gay-Lussac's law of combining volumes. So when reaction happens among gaseous reactant to give gaseous product, it happens in terms of volume. Okay, see, 1 volume of hydrogen reacts with 1 volume of chlorine to form 2 volumes of HCl gas. However, if I am taking, let's say, NaOH in aqueous and HCl in aqueous, then that will obviously give me NaCl and H2O. NaCl will be aqueous, H2O will be liquid. So since these are not gases, we cannot apply that. Okay, sometimes questions come. You should not confuse this. These are applicable only for gaseous reactant giving gaseous product. For aqueous, we cannot apply volume. We cannot say 1 liter of NaOH and 1 liter of HCl will give 1 liter of NaCl and 1 liter of water. This is wrong. Instead, in this case, we should say 1 mole. What is mole? Let's say it little later. Okay. So 1 mole will give 1 mole, 1 mole. That's what we say. Okay. Which I'll explain little later. Okay. Yeah. So similarly, we can take example of 2SO2 giving O2 with reacting with O2 to give 2SO3. Even in this case, all are gaseous. So I can say 2 volume will react with 1 volume to give 2 volumes. Okay. So it will be in 2:1:2. Clear? Yes. Yeah, these are few of the basic laws. However, certain laws were proved wrong. Okay, for example, the law of constant composition. Yes, in certain cases, when there are few defects in compound, it may not be a constant composition. Okay, it may be little less or more. Yeah, and law of multiple proportion. Even this was little, yeah, didn't obey for certain compounds. Yeah, and also law of reciprocal proportion for bigger atoms, molecules, it didn't obey. Okay. Yeah, but in general we use this because it is applicable for our from our point of view, it is applicable throughout 11th and 12th. Okay, so exceptions and all they won't ask. Yeah. Dalton's atomic theory. The main points of Dalton's atomic theory are as follows. So all of you might be knowing what exactly Dalton said about atom. He was the first one to propose about atom, isn't it? So he told that atoms are the indivisible particle of a matter, isn't it? So he told matter is made up of extremely small indivisible particles. These are called as atoms. Atoms of same substance are identical in all respect. That is, they possess same size, shape, mass, chemical properties, etc. Yes. So, yeah, if you consider one particular element, it will always have the atoms which are similar, which are identical. Okay, they have same size, shape, mass, chemical properties. Yes, now since you have already mastered inorganic chemistry, you already know all of this, isn't it? Yeah. Third one, atom of different substances are different in all respects. That is, they possess different shape, size, mass, and chemical properties. Okay, so yeah, they will have a set of different properties. For example, I cannot compare hydrogen and oxygen, right? Hydrogen will have their own properties, oxygen will have its own property. So both will be different. Yes. Yeah, that's what he said. Atom is the smallest particle that takes part in chemical reaction. This is also true, isn't it? So atoms take part in reaction. In case of compound, molecules take part in reaction. Yes. Atoms of same element or different element may combine with each other in a fixed simple whole number ratio to form chemical substances. Yes. So this is also true. For example, H2 will combine with O2 to give H2O. Isn't it? So 2H2 will combine with O2 to give 2H2. As you can see here, two molecules of hydrogen will combine with one molecule of oxygen to give two molecules of water. But during Dalton time, the diatomic concept was not known. So Dalton didn't know that hydrogen can exist in H2 form also. He was saying why hydrogen should pair up with its own, isn't it? Yeah, so we don't like our own brother so much, isn't it? We like friends outside our own home. Yeah, in the same way, hydrogen, why will it try to form bond with same hydrogen, same atom? It cannot. It can only form bond with another atom. Yeah, so that's what Dalton's conception was. So according to him, hydrogen should combine with oxygen. Two hydrogen should combine with oxygen to give one water. So this is what his idea was. But in reality, what used to happen? Two molecules of hydrogen was combining with one molecule of oxygen to give two molecules of water. Okay. Yeah. But however, this was then discovered that atoms can be diatomic, can form diatomic molecules. Yes. So then, yes, that was one of the drawback of Dalton's atomic theory. Yeah. Going ahead, atoms can neither be created nor be destroyed. That is, atoms are indestructible. This is also obvious. By now, you all might have understood, isn't it? If you split the atom, property of atom goes away. Yeah. But there were certain drawbacks to Dalton's atomic theory. Okay. So he was telling atom was no more divisible, but later we are studying that atoms have certain subatomic particles like electron, proton, neutron, and now we are having so many subatomic particles, isn't it? All of that are not included in Dalton's atomic theory. He just gave one sphere as atom. He told that this is atom. What is there inside that? Nothing is there. Okay, this itself is final. Inside this, you cannot divide. You cannot divide. That's what is Dalton's atomic theory. It failed to explain how atoms of different elements differ from each other. Yeah, he didn't give much explanation of how different atoms differ from each other. Yes. Is it that hydrogen is blue in color, hydrogen atom is blue in color, red is oxygen, something like that, or something else? He couldn't explain that. Okay. Failed to explain how and why atoms of elements combine with each other to form compounds, yeah, or molecules. Okay. Yes. So this we now know because all of you might have already covered chemical bonding and all of you might be knowing the reason why atoms should form molecule, isn't it? Atoms should form molecule because they are hankering for attaining stability, and they attain stability by going into noble gas configuration, fully filled octet, isn't it? That's why they form molecule. Yes, it failed to explain the nature of forces that bind together different atoms in chemical substance. Basically, he was unaware of van der Waals force, so he didn't explain about it. Yeah, nuclear reaction, isotopes, and isobars posed serious challenges to the basis of this theory. So, isotopes and isobars, I think you all might be knowing about it, isn't it? Isotope means having same atomic number but different atomic mass. Yeah. So yes, so these are all were few drawbacks of Dalton's atomic theory, yeah, which he couldn't explain. Yes. Yeah. So now we are going into more detailed analysis. Before going into empirical formula and molecular formula and so on, I want to give you a brief introduction about how gradually the theory evolved. Okay. Initially, Dalton's atomic theory explained about atom. He gave a vague idea about what atom is and a few properties associated to it, and then they understood that molecules also exist, which is formed by combination of atoms, and then since they were unaware of electron, proton, and neutron, they were not aware of atomic number at all. They were only aware of atomic mass. They were aware that every atom will have some mass. How much it will be, they don't know. So what they did, they kept hydrogen as reference. Okay, they told hydrogen's weight, let it be 1 unit. Okay. Yeah, when you go to some village shops, they may do like this. If they don't have any standard unit of 1 kg, yeah, that stone will be there, no? 1 kg stone. If they are not having that, then they will keep approximately some stone which is having 1 kg weight, and with that they will balance whatever fruits, whatever vegetables you are taking. isn't it? In the same way, here also they were unaware. Hydrogen's what is the mass? That was too early, right? Now we know that it is 1.6 into 10 power minus 27 kg. 1.672 or 675 into 10 power minus 27 kg, which is too less, isn't it? So this they couldn't find. So what they did, they considered hydrogen to be 1 unit. Then if someone is asking what is the atomic mass of oxygen, they compared oxygen with hydrogen. They told, okay, oxygen is 16 times more than hydrogen. So 16 into 1 unit. So it is 16 units. Getting it? So this is how they came up with the idea of atomic mass. But now we are having something else. What are all those things? That we will look in the next topic, that is empirical formula and molecular formula. Okay. So basic constituent of matter. Yes, atoms are the basic constituent. Molecules, compounds, all of this form basic constituent. So atom is the building block of matter. This contains proton, neutron and electron. Yeah, atom represents the chemical nature of an element, isn't it? That is the smallest particle which behaves, which carries the property of a matter. Molecule, covalently bonded atoms, atoms of same type or different type combined to form molecule. For example, H2, N2, O3, all of this. Compound, ions of different atoms forming a solid structure due to electrostatic force. Yes, these are also molecules, but in this, ions are combined together to form a molecule. So these are called as compound. Clear? So covalently bonded atoms. I hope you all might be knowing what is covalently bonded atom means. What does ions mean? Isn't it? So here basically ionic bond form between two ions, and here covalent bond forms between two atoms, H and H, N and N, and triple bond N, hope you all might be knowing, and O, double bond O, and then one coordinate bond. So here there will be plus, here there will be minus. So this is how the covalent bonds are formed, and this is how ionic bonds are. Okay, so this is the basic constituent of matter. Yeah. So atomic mass, as I said, mass of single atom of an element. Yeah. So but we don't know how much is the weight of single atom, isn't it? Which gradually now we are going to learn it. Okay. And remember, these are all few basic things that you should be aware and clear of. Okay. Because ahead you will be using it very often. Okay. Yeah, mass of single atom of an element is atomic mass. Atoms are tiny, and it is not possible to measure the mass of single atom. I had said, isn't it? So what they did? They approached relative mass method. It is possible to determine relative masses of different atoms. I said, na? Oxygen can be told it is how much time more than hydrogen, but individually atomic mass we cannot. But relatively we can tell. If small unit of mass is taken as standard. I told na, small unit of mass, that is hydrogen, that is taken as standard. It is 1 unit, like that we have taken. Okay. Previously this standard was mass of 1 atom of hydrogen and taken as unity. Later on it was 1/16 part of oxygen atom. Yeah, then they moved to oxygen, and currently we are using C12 atom. Okay. Yeah, 1/12 part of C12 atom. What does the C12 means? It means carbon 12 isotope. That means this is that isotope of carbon which has atomic mass of 12 units. Okay. What is this unit? I'll explain very shortly. Okay. Yeah. Why we are only considering C12? Because we are considering 1/12. Isn't it? Then only I'll get unit. If I use C14, then the unit will be 1/12 into 14. Mass of unit part of an atom will be 1/12 into 14, which is not what we want. Anyway, I'll explain this in more detail ahead. So atomic mass unit is 1 by 12th of C12 atoms. Okay. This is something I would like to elaborate upon now. Okay. Yeah. So atomic mass unit, they are telling it is represented as U, which is 1/12 of C12 atom. My dear students, this is something very important that you all have to focus upon. Okay. Yeah. Till now, if you are not focusing, now focus upon this. Yes. So what exactly atomic mass unit means? It means, in simple words, I can tell it is mass of 1 unit of an atom. Okay. Yes. So always when we consider atomic mass, when I tell atomic mass of hydrogen is 1, what does that mean? I think in 9th and 10th you might have studied. Atomic mass is number of protons plus number of electrons. Sorry, number of neutrons. Isn't it? So number of protons plus number of neutrons gives me atomic mass. This is what you all have learned in 9th and 10th. Yeah. But now I'll tell you why we consider number of protons plus number of neutrons. Okay. If I look into mass of proton, mass of neutron and mass of electron, does anyone know what is mass of proton? Yes. It is 1.672 into 10 power minus 27 kg. Okay. This is some figure which you should be knowing. Okay. Sometimes it will be helpful. Of course, if you want to play with numbers, this is something very important which you should be knowing. Okay. Mass of neutron is also near to mass of proton, which is 1.675 into 10 power minus 27 kg. And mass of electron is least, which is 9.1 into 10 power minus 31 kg. So that's why whenever we consider atom, let's say helium has 4 protons, 4 neutrons and 4 electrons. But since mass of electron is very small, okay, mass of electron is 10 power minus 31 compared to mass of neutron, which is 10 power minus 27, and this is also 10 power minus 27. So I can ignore this, isn't it? So that's why we don't consider this, and we consider mass of proton and neutron to be almost equal, which is 1.67 into 10 power minus 27 kg. Yeah, it is approximately same. So I can tell safely that atomic mass is 4 plus 4, 8 into mass of 1 unit of an atom. 1 unit of an atom could be proton or neutron, whose value is 1.67 into 10 power minus 27 kg. Got it? So that is what this AMU means. So either I can write 8 into 1.67 into 10 power minus 27 kg, or I can write 8 AMU. Got it? Because this is only the mass of 1 unit of atom or atomic mass unit. Clear? Yeah. So that is why we came up with AMU as 1 by 12th of C12 atom. So now can you tell me, when I tell C12 atom, what does that mean? What does C12 means? It means 6 protons are there, 6 neutrons are there, isn't it? That's what it is. Atomic number of carbon is 6. So 6 protons should be there. The remaining out of 12 will be neutrons, which is 6. Yes. So totally there are 12 units in carbon, and unit of the weight of 1 unit will be 1/12 of 1 carbon atom. That will be weight of 1 unit, isn't it? Because 12 units are there in that. So I have to divide by 12 to get weight of 1 unit. That's how we define atomic mass unit. Clear? Yes. So that's why I can tell atomic mass of hydrogen can be equal to 1 U, where U represent mass of 1 unit of an atom, which can be 1.67 into 10 power minus 27 kg or 1 by 12th of C12 atom. Clear? Yes. Carbon atomic mass is 12U because it contains 12 units. So 12U, 12 into weight of 1 unit. Nitrogen is 14U, oxygen is 16U, fluorine is 19U, sodium is 23U, and so on. And one more thing to notice over here is that few has fractional units, isn't it? 35.5 U. U means units. Mass of, U means mass of 1 unit of an atom. So 35.5 units, it is very difficult to comprehend, isn't it? So that's why we have something called as average atomic mass, which explains this. Why chlorine has 35.5. Yeah. Similarly, hydrogen also, if you go exactly, it will be 1.008. Copper 63.5. Why exactly it is? That is explained in this average atomic mass. For elements are found in different isotopic forms. Atoms of same element having different atomic mass. Isotopic form means what? Atoms of same element having different atomic mass. So the atomic mass of any element is the average of all the isotopic mass within a given cell. So how to understand this? Let's say in this universe, I have two types of chlorine. Rather, I would say two isotopes of chlorine, in which atomic number will be same, 17 and 17, but atomic mass in one case is 35, another case is 37. Okay, so then let's say if this is 75% of the whole chlorine atom present in this universe, and 25% is say 37Cl17. So then average of this is what we fix as atomic mass of chlorine. So what will be average of this? 75% of 35 plus 25% of 37 is the average, isn't it? Yeah. So I think in 10th you might have heard about weighted average. Yeah. So what does weighted average means? Weight is 75% for 35Cl17. So 75% of 35. And for 37Cl17, weighted average is 25% because its weight is 25%. So 25% of 37. So it will be 75 by 100 into 35 plus 25 by 100 into 37, which will be equal to, if you perform calculation, this is 3 by 4 and this is 1 by 4. So that will come out to be 35.5. Now what will be the unit of atomic mass? It will be U. Yeah. So the answer will be 35.5 U. Or else, if you want formula, there is a direct formula to use this. Okay. So which is percentage abundance into atomic mass. Summation of that will be average atomic mass. Okay. So in that way, if I want to tell, it is 75% into 35 in this case, plus 25% into 37 divided by 100, which is 35.5 U. Yeah, so this is why few of the atoms will have decimal in their atomic masses. Yes, so with this knowledge, can you find out atomic mass of argon if their isotopic masses are given as 35.967, 37.962 and 39.96, and percentage abundance given is 7.1, 16.3 and 76.6. Just try it out. Yes. So if I want to use direct formula, then it will be average atomic mass equal to summation percentage abundance into respective atomic mass divided by 100. So what will be the answer in this case? What could be the answer? It will be, for first case, it is 7.1%, isn't it? So I can take it as 36 for easy. 7.1 plus 16.3 into 37.96, which I can take it as 38, plus 76.6 into 40 by 100, isn't it? Yes. So if we simplify this, how much will we get? Yes, it will be 39.352 AMU. Okay. Yes. Next is gram atomic mass or weight. This atomic weight of an element in grams. Yeah. Whenever we are writing atomic weight in grams, for example, in case of hydrogen, we know that atomic mass is how much? Just now we learned 1. Till now, whenever atomic mass used to come, I think all of you used to write just this number. But from now on, I want you to write it as 1U, because 1 as such does not make any significance, doesn't it? When you say 1U, then it makes significance. That means the weight of mass of one atom is 1 into how much is U? Never forget this value. Okay, it is 1.67 into 10 power minus 27 kg. So I can say 1U will be 1 into 1.67 into 10 power minus 27 kg. Or I can say it is 1.67 into 10 power minus 27 kg. Can you just imagine how small is this number? Yes. Can you just imagine? Yeah, just try to let us try to understand. 1 kg, yeah, is something which you can comprehend. 1 kg of sugar, 1 kg of rice, yeah, which you can think of, isn't it? 100 grams, yes, we can think of. We purchase certain items in 100 grams also. 10 grams, yes, we purchase certain items in 10 grams also. 1 gram also okay. Yeah. 1 milligram, this also sometimes we have done. Yeah. How much is 1 milligram? It is 10 power minus 6 kg. Okay. So this is what you can imagine. But 10 power minus 27 kg is far beyond imagination, isn't it? Yeah. So that is why we have something called as gram atomic mass, which is for our ease. What does gram atomic mass means? If hydrogen is having atomic mass of 1U, instead of writing U, you write 1 gram, and that will be gram atomic mass of hydrogen. Clear? So, yeah, if you are having any doubt till now, you can just comment. Okay? You can just comment. Meanwhile, I'll just try to complete this because this is crucial part. Today's class is a crucial part which will take us up in physical chemistry. Okay. Yeah. So just erase this. Yeah, atomic weight of carbon is 12 AMU. So gram atomic weight will be 12 gram. Instead of AMU or U, I am writing gram. Okay. And this is also equal to 1 mole. Always remember, you can write down in your notes gram atomic mass of any substance. Gram atomic mass of any substance will contain 1 mole of atoms in it. 1 mole of atoms in it. To make it more generalized, you can write gram atomic mass or gram molecular mass. Gram atomic or molecular mass of any substance will contain 1 mole of atoms or molecules in it. Clear? Yeah, what exactly 1 mole means, that I'll teach you next class. Okay, yes, let's try to complete this off. Atomic mass unit, AMU, value will be in gram per kg. Yeah, so gram atomic weight of carbon is 12 gram, which is equal to mass of 1 mole atoms of carbon. Okay, mass of atom of carbon is 12 gram by Avogadro number. What does this mean? This also I'll keep it for next class. Okay, it is called as Na. What does Na means? Let us look it in next class. And then atomic mass unit, this is 1/12 of C12 atoms. So I know that C12 atom has a mass of 12 gram of Avogadro number. How exactly is this? Let us look in the upcoming class. Okay. Before that, I want you to know what is Avogadro number. Yes. So there are 2 ways to find atomic mass. Till now, I gave you information regarding atomic mass, molecular mass, and then we looked upon molecule and compound. Briefly, we looked into atomic mass. I told about atomic mass unit and then gram atomic mass. Now we are looking at methods to find atomic mass. One is Dulong-Petit's law, which is based on specific heat. Okay, so atomic mass into specific heat will be always equal to 6.4. From this information, for any matter, if you know specific heat, you can find out atomic mass of it by substituting in this formula. Okay, it should be calorie per gram. Yeah, that is Dulong-Petit's law. This law is not applicable to light dark elements like boron, carbon, and silicon. This one thing you should be careful of. Clear? Second is Cannizzaro method, which is used more often. Okay, how they are finding atomic masses in it? In this, they are considering various compounds which contain common atom in it. Okay, common atom. For example, in this case of ammonia, which is NH3, nitrogen oxide, nitrous oxide NO, nitric oxide NO2, N2O, nitric oxide NO, nitrogen peroxide NO2, nitrogen trioxide NO3, and so on. So in this case, nitrogen is common, NH3, N2O, NO, NO2, and N2O3. In all this case, nitrogen is common. So when you consider molecular weight and nitrogen weight in it, you will find that one has 14, one has 28, one has 14, 14, 28. So whichever is minimum among this, that happens to be atomic mass of nitrogen. That's what Cannizzaro method says. Clear? If an element has several compounds with other same or different elements of known atomic mass, then the compound that has minimum presence of former element indicates the atomic mass of the element. Okay, so if you know the molecular weight and if nitrogen mass in a compound is same or different, okay, it is same or different, then whichever is minimum, that will be the atomic mass of that particular atom. Okay, this is what Cannizaro's method says. Fine. So next class, let us begin with mole concept. What exactly Avogadro number means? What does 1 mole means? And how 1 AMU can be obtained from this information? All of this, let us look at in the next class. Okay. So happy Makara Sankranti to all of you. With this, let us end over. Thank you.